What's going on, guys? My name is Amos and I'm back again with another video. So in today's video, we want to sort of like start our project. So the very first thing that we're going to do is, open a blank, Visual Studio code window, and we're sort of like going to create all the folders that we will need to use in this particular project, and we'll sort of like create everything from scratch. Now, the very first thing that we need to do is to sort of like create a make file. So to be able to build our project, we'll be using CMake. So I'll sort of like I'm going to create a new file, and then I'm going to call this is going to be our make file, like so. Make file, like so. So this is going to be like our make file. I'm going to leave it, as it is. So this is going to be our make file. The next file that we need to add is a .gitignore file that we will need to add, like so. So we'll have a .gitignore file, and then let's add a folder, right? Let's add a folder. Let's go back here. Let's see if we can add a new folder. Now the first folder is going to be include. So this is where we're going to put our header files, right? So this is where we're going to put our header files. So have an include folder. Then we'll also have another folder which is going to be build, like so. So apart from the build folder, we are also going to have, not inside the build folder, right in the root, we're going to have another folder that we're going to call bin, bin folder. So this is where we're going to put all the binaries, and we're going to also have, now let me think, what other folder do we need? We're going to have a source folder. This is where we're going to put all our .c files. All right, this is where we're going to put this is where we're going to put all our .c files. And yeah, if we need any more, we are also going to have a test folder, a folder where we're going to put all our tests. So I'll just call it tests, like so. And we probably need a folder where we'll put our examples, so for people to see. And I'll also create another file. It is going to be the readme .md file, like so. So this is like, our documentation. So I'm going to like close this. We don't need to update our Visual Studio now. We'll do it a little bit later. Now the very first thing that I want to do here is to create the very first thing I want to do here is to create our very first header file that is going to like hold the definition of our automaton structure, right? So I'm going to like put it there. I'm going to like create it. So I'm going to say new file, and then this file is going to be automaton.h, like so. This, hopefully I've spelled that word correctly, automaton. So I believe that's how it should be written. So the very first thing that we want to do here is to add our guards. So if not defined, go ahead and so I'm going to just say automaton then underscore h, like so. So if this is not defined, we'll go ahead and define. Go ahead and define automaton. Of course, I'm going to like mess up things, and yeah. So, and if not defined, and if not defined, like so, and we just want to like put this here, automaton h, like so. So we've added our guards and everything is okay. Now the very first thing that we need to do is sort of like define the structure. How are we going to represent this automaton in memory? Now the very first thing that we need is we need to like break the entire structure into separate structures. So the very first thing that we're going to need is going to be an alphabet. So an alphabet is basically a collection of symbols. So how are we going to like represent an alphabet in memory? So what we're going to do here is we can say type def. So we can say type def, we can define a structure, and this structure here is, so all the types that I'm going to define are going to be prefixed with a underscore. So a for autonLib. So they're going to be prefixed with a underscore. So here we're going to say this is like the alphabet, all right, alphabet, and then underscore t, like so. All right, so this is our type. So we define a type, and we will first of all need, well, it's a set of symbols, right? So we're going to sort of like have here we can just say we can also have strings, right? We can also have strings. So because we can also have like strings, because it's not like in the English alphabet where we have like single characters like a. So well, a symbol can be anything, right? A symbol can be anything. A symbol can be anything. So we want to like store them as strings. So we need to do something like this. So members. So we're going to have members, like, so we probably also need to have the length of the alphabet. So this is going to help us, especially if we want to sort of like loop through the items. So we'll basically look at this particular variable length. We'll initialize it to 0 and sort of like increment it each time we add a new item to the alphabet. So we'll need that length. Well, that has been done. Well, let's now move to the second item. What else do we need? So we need states, right? So we need states. So we need states. But well, to make this work, right, we need states. So let's look at the structure state. So let me also define a new state, a new structure. So I'm going to call it type def struct, and this is going to be an a state, like so. This is going to be an a state underscore t, like so. Now these names might change if I discover that these things are not making sense, or maybe they are too long and all that. Well, a state is going to have a representation. A state is going to have a representation which is going to be a string, right? Which is going to be a string. So we can have char, and then this is going to be rep, like so. This is a string. So for now, we'll sort of like we'll restrict people to sort of like give reasonable names to their states. We don't want them to give states very long names or anything like that. That won't be like something that is like good to have. So we sort of like are going to limit the naming. So we'll say define. We'll define a max. Maybe we'll say state. We'll call it state representation. I'm going to shorten the word representation so that we don't have to like write the whole thing. State representation length. I'm going to say 10 characters maximum. That must be the name. And I want to sort of like come back here and sort of like include it here and say here I want maximum state representation, and of course we have to close that with a semicolon. What else do we need? So the first thing that we have to do here is to sort of like I'm going to say type def. I'm going to say bool t, like so, and then int, like so, right. Okay. Well, actually, we'll just leave it the way we'll just use raw int. Okay. So let's look at the characteristics or the attributes of a state. So what properties does a state have? For the first thing that a state has, we first of all need to know if our state is a starting state or an ending state. So we'll say int. So here we'll just go is starting, like so, is starting, like so. We need another int is ending. So if it's a starting state, we'll initialize it to 1, for example. If it's not a starting state, we'll say 0. So same thing. So I think here we have to say not is starting, but is ending, like so. So if it's an ending state, so that is what we have there. So is starting, so we have a representation. We have, is it a starting state? And of course, for this to make sense, let me just say is starting state. And let me also say is ending state. That is cool. Another thing that a transition is, that a state is going to have is, transitions, right? We need to keep track of the outgoing transitions. For every state, we need to sort of like keep track of the outgoing transitions. Right. So how do we do that? So we need to keep track of the outgoing transitions. Okay, well, the very first thing, before we even talk about how we're going to like, before we even like add that to our state structure, we need to think about how we're going to represent these transitions. So what I'm thinking is we're going to sort of like represent these transitions. We're going to put all the transitions in a linked list. Okay, if you don't know what a linked list is, I'll sort of like explain what it is, a little later. But for now, I'm going to just put all the states all the transitions in a linked list. Okay, in a linked list where where the state is basically going to point to the head of the linked list. Okay, to the transition, to the transition at the head. All right, the head position of the linked list. So that is where the state is going to point. And if we need to like look at all the transitions, we basically have to sort of like loop through all the we have to loop through the linked list and sort of like make sure we loop through until we reach the end. All right, until we reach the end. So what we need for that to work is some sort of like node, right? We need some sort of like node to help us with with that. Okay, so type def. Let's go type def, and then let's say struct like so. And what this is supposed to have is, now let me first of all close this like so that it doesn't give us errors. So we're going to have I'm just going to say t node like so, a t node like so. So that is our structure. But then if you look at a transition has a starting state and an ending state. So what I probably have to do here is to sort of like forward write two forward definitions here for the for the state and for the transition node, because these two sort of like depend on each other. So I'm going to say type def, and then I'm going to say type def we're going to just say type def a state. Is it what did we call that? We called it a state t like so, a state t. Want to say a state t like so, and then we also have to do another type def. We're going to go struct, and of course let me just zoom in a little bit so that you see what is happening here. A t node like so, a t node, and this has to be an a t node, something like this. I don't know if it makes sense. So this is what we have here, right? Right, so this is what we have. So these two are going to like depend on each other. So what we're going to do is we'll need a pointer to the head of the to the head of the transition linked list. So here we're going to say a transition node like so. I'll probably change the names, maybe use uppercase letters or something like that to make these things look a bit nice and all that. So we're going to say a t node, a t node, and of course this is going to be a pointer, right? So we're going to say pointer to, so this is, maybe just say maybe let's just say head, let's just call it head like so. That's good. So we have a pointer to the head, and we basically have to also like store the number of outgoing transitions. So let's just say out and then transitions, just complete write the full thing. So that is going to give us the number of outgoing transitions. So the transition itself, the transition node itself, is going to have a few properties, a few interesting properties. For example, we need to store what symbol we are reading with that particular transition. We need to store the symbol we are reading with that particular transition. So to store the symbol we are reading with a particular transition, we'll need an input symbol. Again, I think this is where we'll sort of like restrict them. We need like a symbol length here. We need like a symbol length like so. Or what we can do is we can sort of like write it as a pointer to a string, right? A pointer to a string, because we need to sort of like match the item that we have here. We need to match the item we have here. So this has to be like a pointer to the, so we'll just say symbol like so. I'll just call it symbol, or let's just call it input symbol like so. Let's just say input symbol. And of course, if there's something that is that goes wrong with this, we'll basically change it. It's not a big deal. So we've already done the forward definition. So we'll say a state. So we'll have an origin. So we'll have from, let's just call it from like so. We'll have a pointer, and then we'll also have a to pointer. I'll just say to like so. What else do we need? Remember that we will put them in a linked list. So every transition a particular transition has to sort of like allow us to get to the next state. Okay, for a given state, we have to sort of like find a way to sort of like get to the next transition. All right, we have to like get to the next transition. So we're going to have a pointer to the same structure, to another transition, to another node, or to another transition node, and this pointer is going to be next, right? We're going to call it next. So this helps us to like get to the next transition. This helps us to get to the next transition. So for now, this is what we have here. So we have the alphabet, we have the state, and then we have what else do we have? I think we have we also have we have the state, we have the transition node, then we have the alphabet. Well, the next thing that we have to do is to define the now the overall structure, the automaton structure, right? That's the only thing that we have to do here. Well, what we're going to do here is to define the structure. We'll also have to say go type def, and then we're going to say struct like so. And of course, we're going to make a lot of mistakes here. And then we also have to like keep track of the num states, and that's how we're going to learn and how we're going to change things. Of course, I need to close this with a semicolon. That's just we need an alphabet. We need a pointer to the alphabet. We need a pointer to the alphabet. Or here we need a pointer to the alphabet. So we'll say alphabet like so. We need a pointer to the alphabet. That looks good. We need a pointer to the alphabet. We also need a dynamic list, a dynamic array that is going to store the states, because we want to store every state as a pointer. Okay, we want to have pointers. Okay, we want to have pointers. So we need to store we need a set of states where every state is a pointer, and we basically need to point to that dynamic array. So to be able to achieve that, what I want us to do is to have is to have an a state like so, and we're going to have a double pointer here, because every state is a pointer. And this points to a dynamic list. This points to an array of states, right? So it's going to be a double pointer there, and then I'm going to call it states like so. So an automaton has an alphabet. We also have a number of states, and then it also has states. It has an alphabet. It also has a number of states. So if we basically want to loop through all the states of the automata, we'll basically need length here. We'll basically need length. So here I'm just calling the length num states, and probably we should sort of like rename this this length that we have here for the alphabet to num. We'll just say num members like so. I don't know if that makes sense. I think that's better. That's better. So this is our structure. So let's first of all go through what we have here. So first of all, we have this. Okay, we have this, and then we have a struct here to store the transitions. They'll be in a linked list, and then here we have a state, and then here we have the overall structure for our. Of course, we need to give this a name for it to work. So we have A, and then automaton, and then T like so. Okay, so this is what we have here. This is what we have here. And of course, now it makes sense. Let's first of all see if this actually compiles. Let's see if this compiles. So this is our initial structure. Of course, if we have problems with this structure, we'll come in and change a few things. Of course, in the next video, we'll look at how we can sort of like come up with methods to initialize all these structures here, like the structure for storing the alphabet, the structure for storing the transition nodes, the state, and all of that. And of course, I'll also like think about the names. We'll probably use maybe maybe we'll probably use a different convention for like naming these or something. So we'll probably use uppercase letters or something like that, right? We'll probably do that. Okay, we'll do that in the next video. Thank you guys for watching, and I'll see you in the next video.